So thank you very much for giving me this opportunity. So I'm Nissen Lazreg, doctor in science and technology in the field of space engineering. So I represent the Center for Research on Microelectronic and Nanotechnology. Today I will present the benefits and the challenge of multi-GNSS for Africa. With this presentation, I will begin with the introduction, and I will list and talk about the multi-GNSS in Africa. I will talk about the GNSS needs in Africa and the emergent applications of GNSS, and then I will finish by the conclusion. So, by introduction, the GNSS is an umbrella term that includes any satellite's navigation system. So, the multi-GNSS include using of several systems, like GPS is an US operational since 1994. And the Russian GLONASS, it was operational since 2010. Then the Galileo, it's an European Union GNSS with anticipated operation 2019. And the last one, the Baidu, it's a China system operational in Asia and Pacific since 2012. So then this slide presents the GNSS landscape in Africa. In Africa, we have 54 individual nations with multicultural structures. So Africa is a continent with a very high linguistic diversity. There are between 1,500 to 2,000 African languages, with English, French, Portuguese, Arabic, Spanish, religions, different religions, political organization. Africa, it's 30 billion kilometers square and 1,400 million people in 2022. So then I list the multi-GNSS situation for Africa. This figure presents the GNSS coverage in Africa. 37% of Africa is 250 kilometers from an ELS equipped airport, and 87% of Africa is 250 kilometers from a main or regional airport. So the goal is address the special needs of landlocked developing countries and the small island developing states. Now, I will present the S-bus GNSS systems in Africa. In Europe, we have the European Geostationary Navigation Overlay Service, EGNOS. In the USA, we have the Wide Area Augmentation System. In Japan, Mitsubishi Satellite Augmentation System. In India, the GPS-aided geo-augmented navigation. In China, Baidu S-bus system. In South Korea, the Korea Augmentation Satellite System, Russia System for Differential Correction and Monitoring, the ASE Siena Augmented Navigation for Africa, ANGA, it's in development. In Australia and New Zealand, the Southern Positioning Augmentation Network. We can see with this map this distribution of all S-bus GNSS system in the world. So less than 20% of runways are equipped with the instrument landing system in Africa. Between 2000 and 2015, controlled flight in terrain equal to 20% of fatalities, most of them occurring in the approach landing phase and being often associated with the emphasis approach. The SBAS helps overcome known safety and operational limitations of the technical constraints of lateral navigation and vertical navigation operations. We see the reduced maintenance costs of legacy systems and calibration requirements. So SBAS is a cost-effective solution in complement to the ALS. This slide presents two figures to map the first about this distribution of GNSS scores on the Africa. This represents the PNT infrastructure and on the continent of Africa, and the PPP, the precise point position in the Africa. Then I list the progress on the implementation of the GNSS in Africa. The implementation of SBAS is ongoing, under development on the continent, with more than half of African Union members involved in development programs like Agency for Air Navigation Safety in Africa and Madagascar. And with the Arab Civil Aviation Organization. Also in Africa, the UNISEC support program, a partnership between Africa and the European Union, is championing a roadmap for the development of GNSS applications and the implementation of EGNOS service across the continent. More, we can see the Nigerian ComSat, the first Nigerian ComSat as a hybrid satellite for GNSS augmentation, is a hybrid satellite with a navigation L-band payload for a space-based augmentation system, meant to provide a navigation overlay service similar to the European geostationary navigation overlay service EGNOS. Other related projects covering Africa in the framework of the 7FP and the H2020. So among the projects which have been awarded in the frame of 7th framework program. This project, it's about the SBS and SBAS, and Africa. It presents the CIRAJ SBAS implementation in the region of Arab and Africa. The ESA, the EGNOS service extension to South Africa. The third, the awareness in Africa, and the last, the SAT. It's SBAS awareness and training in South Africa. Then I will talk about the African needs, accurate and misusing of GNSS. So the GNSS is vital for science. GNSS enable amazing information technology with navigation, surveying, geodesy. Geodesy, the science of measuring and monitoring the size and shape of the Earth, understanding change and complex dynamic process of our home planet to better protect our world and the continent. It's a future of IoT infrastructure and increasing importance of GNSS technology. So the needs of GNSS technology in Africa focus about the surviving, the road transport, aviation, maritime transport, wildlife conservation, like environment and agriculture, civil protection, and surveillance. Also, GNSS in Africa can contribute to monitoring the Earth, like earthquake, volcano, storage, etc. Also, with GNSS in Africa, we can mapping of well and result. Also, GNSS in Africa can contribute to protect and control of animal and wildlife protection. Now, the new challenge of GNSS in Africa. So the first challenge with the new technology, remote sensing by multi-reflected GNSS. So this application with the GNSS reflected at the Earth's surface allows to monitor rate of water levels, as well as that the determination of different properties of ocean surfaces and terrestrial. The reception by nanosatellites of our tower, and measurement of snow depth, vegetation growth, ocean tides, or SNM. Also, with the GNSS in Africa, we can contribute in atmospheric and geophysical research with the characterization of the ionosphere using tech, space weather studies, scintillation studies, atmospheric delay, validation improvement of existing atmospheric models, water vapor estimation, climate change studies, seismic studies, etc. Also, GNSS in Africa can contribute in social economic approach on increasing level, like positioning service, surveying and mapping, boundary mapping, food security, disaster management, airland and sea secure navigation, land administration, emergency response, wildlife management, etc. So with the multi-GNSS regulation, we have freedom of use and exploration of for the benefits of all mankind, with sovereign with multi-GNSS using cybersecurity and GNSS application, more accuracy GNSS research and development, responsibility of states for national activity. Now, for the recommendations in Africa, so we need some intensified complementary efforts at densifying the GNSS ground infrastructures, development of prerequisite physical infrastructure for GNSS facilities. We need internet connectivity and access to energy. Now I finish with the conclusion. So multi-GNSS provides a unique and valuable tool for observing and understanding our planet, like climate change, sea level change, ice and glacier melting, earthquakes, tsunami, volcanoes, etc. With scientific observation and understanding can lead to actions in order to better protect our world or our continent today and for future generations. SBAS adoption in aviation sector in Africa aligns with the single African air transport market agenda of African Union, So a flagship project of the African Union agenda, sorry, it's just a mistake, on 2036 to advance liberalization of civil aviation in Africa through unified sky and acting as an impetus to the continent's economic integration. Thank you for your attention. Thank you.